Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 8. We represent our study on the amount of physical activity among IIM students. First of all, I'm going to introduce my group members as my name is Din Hakiki, followed by Wan Abdul Hadi, Muhammad Hafiz bin Nassim, and Ma Jia Cheng has jointly contributed to the project. Firstly, since we have 6 explanatory variables related to the amount of physical activity, there are 6 objectives. Our main objective are to investigate physical activity among the circle of IIM students only the past weeks with knowledge, gender, MBNA, quality, peers, parental, and planning. Relationship between physical activity and the variables. First, increase in knowledge about health tend to increase the awareness about the benefits of engaging in physical activity. Second, as air pollution level increase, the tendency to engage in physical activity during leisure time decreases. Third, there are negative impact between women and physical activity. An increase in peer and parental influence will increase the amount of physical activity. And lastly, an increase in planning will increase engagement in physical activity.
Part is data resources. In this study, the data used are primary sources, which collected by Google survey with some questions related to variables. The survey was conducted among the student population at IUM Gombe campus by sharing the questionnaire link in person and on WhatsApp. The survey contained was the total physical activity of the student in the past week and the related explanatory variable, which are gender, knowledge, peer, parental, action plan, and air quality. In the end, we got 115 responses. Next part is our regression mode. The amount of physical activity is beta non plus beta 1 gender plus beta 2 knowledge plus beta 3 peer plus beta 4 parental plus beta 5 plant plus beta 6 air quality plus aerodome. Our expectation of this model, beta 1 is expected to be negative. When the gender is female, the expected amount of physical activity is expected to decrease by beta 1. Beta 2 is expected to be positive. As the degree of knowledge increase, the expected amount of physical activity is expected to increase by beta 2. Beta 3 is expected to be positive as the degree of peer influence increases. The expected amount of physical activity is expected to increase by beta 3. Beta 4 is expected to be positive as degree of parental influence increase. The expected amount of physical activity is expected to increase by beta 4. Beta 5 is expected to be positive. Planned physical activity expected to increase the expected amount of physical activity by beta 5. Beta 6 is expected to be negative. As the air index increase, the expected amount of physical activity is expected to decrease by beta 6. This table is the statistic data of the survey, including mean, median, standard deviation, maximum and minimum value of 115 observations.
As you can see in the slide, the model we choose to use is linear model regression without making any log transformations. Our initial result shows that the R-square value is 0.164907, which means 19.5% of the amount of physical activity among IIM students can be explained by all explanatory variables in our model. For the coefficient, we get it by regressing the data in e-views. The model will be shown at the bottom of the slide. Next, the specification error. We conduct the specification error test to check whether our model has an irrelevant variable or use the wrong functional form. To test if our model has specification error or not, we use Ramsey reset test. We set our level of significance at 0.05. The result shows that our critical value is 3.08, which is bigger than our p-value 0.7048. So we accept H0, which means there is no specification error in our model. Next, multicollinearity. The multicollinearity is when one explanatory variable has some or a perfect linear relationship with other explanatory variables. So to test our model, an auxiliary regression test has been used. We regress each of the explanatory variables as dependent variable for each explanatory variable. From the data regression by e-views, we can conclude that we do not have multicollinearity in our model as all the R-square values, which are gender 0.048484, peer is 0.155398, and plan is 0.089297 respectively, are below the cutoff point of R-square value, which is 0.8. Also, the R-square values for parental, knowledge, and air quality show no serious multicollinearity, which are 0.037429, 0.183733, and 0.115892 respectively, because all these values are below the cutoff point, which is 0.8.
For the next test, I will explain about the serial correlation. Serial correlation means the error terms are related to each other. And we use W. Watson test to check whether our model have a serial correlation or not. From e-view, we can see our test statistic value is 2.006202 and our critical value for DL is 1.421 and for DU is 1.670. We can see in the slide our D value inside the accept H0 region. Thus, we accept H0 and that indicates that there is no first order serial correlation. We also can check other order serial correlation by using the Bruch-Godfrey LM test. From the e-view, our F value is 0.001375 and our critical value is 3.08. Thus, we accept H0 and there is no serial correlation. From the test, we can conclude that there is no pure serial correlation problem with our model. Moving to the final test, which is heteroscedasticity. Heteroscedasticity is the variance of the error terms are not constant. First, we will use the part test for each of our variables except gender and plan, as these two variables are dummy variables. The first variable we test is knowledge. From the view, we can see our test statistic value is 0.657428 and our critical value is 1.65851. The critical value is bigger than our test statistic value, thus we accept H0, which means the error is homoscedastic. Same result for the equality, the error is also homoscedastic. However, for parental appeal, we found out that the both error are heteroscedastic, as the critical value is lesser than the test statistic value. The next test for heteroscedasticity is a wide test. From the EView, we know that our test statistic value for chi-square is 35.24612 and our critical value for 0.05 significant level is 37.625. As our critical value is more than the test statistic value, we accept H0 and errors are homoscedastic. As our model have a heteroscedasticity problem for variable peer and parental, we choose to conduct new West test to reduce our heteroscedasticity problem. We use new West test rather than weighted least square methods, as we are not sure about our real form of heteroscedasticity problem in the model.
This slide is about individual significant test. The test for individual significance is done to determine whether each of our explanatory variables in the regression model has a bigger impact on the dependent variable. So we set the level of significance at 0.05. So the critical value that we get from t-distribution table is 1.659. Looking at the results of the t-statistic value regression by e-views for each explanatory variable, we compare them with critical value. As a result, we accept H0 for B1, B2, B4, and B6. Meanwhile, for B3 and B5, we reject H0. This means B3 and B5, which are peer and plan, respectively have a significant impact on the total amount of physical activity among IIUM students. Contrast to B1, B2, B4, and B6, which are gender, knowledge, parental, and equality, have no significant impact on the dependent variable.
For the overall significant test, our F statistic value is 3.554489, level of significance 0.05, and our critical value is 2.18. Because of our F statistic value bigger than our critical value, we reject H0, and we can conclude that our model has an overall significance, which is at least one of the explanatory variables has a significant effect on the amount of physical activity.
From our findings, we can conclude there is two variables are significant and four variables are not. Firstly, air quality are not significant because in Malaysia, especially in IIM, there is no air pollution. While gender are not significant as IIM provide equal facility for both gender. Based on our observation in IIM, on average, both are physically active. Third, knowledge are not significant because all students are aware of benefit of physical activity but lack of motivation. Parental are not significant because students are not with their parents in campus. However, peer shows a significant effect as it indicates the peer influence is more important than parental influence in the campus. Lastly, plan are significant because students with proper plan will have motivation and discipline in doing physical activity. In conclusion, from the data that we collected, we have computed the test statistic. We found that our Ramsey reset test, there is no specification error because critical value is bigger than F statistic. Second, we found that our serial correlation after conducting Bruce-Crabtree serial correlation LM test, there is no serial correlation problem. For all variables that we tested, there are no multi-collinearity problem for every regression model. In conducting the PAC test, there are heteroscedastic errors, while in wet test, there are no errors. To solve the problem, we are using new West method of correlation as a remedial measure. Lastly, our model has an overall significance in which at least one of the explanatory variables has a significant amount of physical activity.